Okay, so continuing with our video lessons, okay, we're going to talk about today of quadratic inequalities. Okay, we already kind of started talking about this topic. Remember that um, when we talk about quadratic inequalities, we will have quadratic equations, but now instead of having the values equal to zero, we might have a greater than, or less than, or greater or equal, or less than or equal. Okay, so we already started talking about this on the live class in Zoom. Okay, so we're just gonna practice with a couple of more exercises so that we can, um, put into practice the topics that we need. Okay, so when we have a quadratic inequality, we have the same form, okay, as a quadratic equation. The only thing is that now we need to convert it into a first inequality. Okay, we have to factor, or using, we might be able to use completing the square, quadratic, formula, or just factoring. Okay, so we bring the terms into two solutions, and then we perform a small graph, and then we write the solution set. Okay, so let's take this quadratic inequality, and then first let's factor. Okay, so we know we will have two terms less than or equal than 0. Okay, we already know that we have x, we have x. Okay, and remember that we're looking for a number that multiplied gives us the number here, and added and subtracted can give us the number here. Okay, so then we know that the first one is a negative and the other one is a positive. Remember that the first one we copy, and the second one is the multiplication between the first one and the second one. So it's going to be positive. Okay, so we're looking for two numbers that multiplied gives us 56, and that added or subtracted, they will give us -1. Okay, so right off the bat, I know that 56 can be divided into 28, it can be divided into 7s, it can be divided into 4s, it can be divided into 8s. Okay, it can be divided in 28. Okay, it can be divided in 2, it can be divided in 1. Okay, so we have multiple solutions. Okay, so let's think. If we're looking for two numbers that multiply will give us 56, okay, multiply. So that means that we can have 7 and 8. Okay, we can have 28 and 2. Okay, we can have 28, 28 and 2. Okay, we can have other divisions for 7, other divisions for 8. Now let's think. If multiply, they give us 56, but added, they give us -1, that narrows it down to 8 and 7. Okay, but remember, that means that the bigger negative number needs to be 8, because when we add them together, -8 plus 7 is going to give us the middle number. Okay, so right off the bat, we know that here it's 8, and here it's 7. Okay, because let's try it out. X times x, x squared. X times plus 7, 7x. Okay, -8 times x, -8x. And then multiply, they give us -56. So when we add plus 7 minus 8x, is going to give us the middle number, which is -1. Okay, now when we have already our two solutions, because remember, these are the solutions. We have x minus 8, and we have x plus 7. Okay, so that means then, okay, this one is 8, and this one is -7. Okay, because when we are looking for the values that are going to make this into 0. Okay, so this is where we get this. Okay, so the next thing we need to do is our table. Okay, we have our table. We put our terms, okay, and then we have our solutions. Okay, so on the first one we have x minus 8, then we have x plus 7, and then we have the solution set, right, which would be just the answers. Okay, so let's graph. Okay, x minus 8, where does it become 0? It's going to become here at 8, and the other one is -7, right? And this one is going to become 0 in minus 7. Okay? But remember, since the inequality is less or equal, that means that these points are included. Okay? They are included in the solution set. Now, what do we need to do with these? Okay, we need to find the symbols, okay, for the solution set. So, the numbers that are to the right of 8, let's say 10, 10 minus 8, 2. So the answers on this side are going to be positive. Let's try numbers that are to the left of 8. Let's try 0. 0 minus 8 minus 8. So the numbers that are to the left of 8 are going to give us negative answers. Let's try this one. Okay, the x plus 7 is going to become 0 at minus 7, but it's included. Okay, so that means that numbers to the right of minus 7, let's try 0. 0 plus 7, positive. Okay, so the numbers to the right of minus 7 are going to give us positive answers. And the numbers to the left, let's say minus 9. Minus 9 plus 7, minus 2. Okay, so that means that the answers to the left of minus 7 are going to give us negative answers. Okay, so the points are included. Okay, and we have negative times negative, positive. Negative times positive, negative. And positive times positive, positive. Okay, so these are the symbols for our solution set. Okay, now what we need to do is put this in a number line, just so that we can see, okay, a little bit more clearly what are we talking about. Okay, so we take our number line and we graph our points. Okay, we know that our points are 8 and minus 7. So let's put 8 here. Let's say that 0 is here, and let's say that minus 7 is here. Okay, so we graph our points. Okay, they are included, remember, because we have a less than and equal. Okay, so they are both included. Okay, so let's look at what we have with our table. This is the reason why we have to, write up this table, because we're looking for the numbers that are going to be included in the solution set so that this inequality is true. Okay, so we're looking for the numbers that come from negative infinite up to minus 7. Okay, so here we have negative infinite. So these numbers are included. Okay, so they come up to here. Okay, all of these numbers are included. From negative 7 to 8, they are not included. Okay, so all of these numbers are not included. Okay, and then we have that 8, okay, is, hold on. Okay, so we have that the values for 8 to the right up to positive infinite are included. Okay? So, how do we know that this is correct? Let's take a number here. Let's take 1. Okay? If x would be 1, let's see what happens. 1 to the square, 1. Minus 1, 0. And 0 minus 56, minus 56. Is minus 56 less or equal than 0? Yes. Okay? Let's try a number to the right of 8. Let's say 10. 10 to the square, 100. Minus 10, 90. 90 minus 56, 34. Is 34 less or equal than 0? No. Okay? Let's take a number to the left of minus 7. Let's say minus 10. Minus 10 to the square, 100. Minus 10, that would be 100 plus 10. So that would be 110 minus 56. That would be 54. Is 54 less or equal than 0? No. Okay? So, what are the numbers that we're looking for that will prove that this is correct? These values, from -7 to 8. So these are the values. In the middle, these are the values that make our inequality true. So when we write our solution set, what we're looking for are these numbers. So -7, not included. Okay? Oh, sorry. It is included. Sorry. -7 is included. Why is it included? Because this would make this inequality true. Let's try with -7, just so that we can have an idea. -7 to the square, 49. Minus -7, what is that? That would be 49 minus -7, that would be 47. Sorry, 49 plus 7. Okay, that would make it 56, right? 49 plus 7, 56. And 56 minus 56 is 0. Is 0 less or equal than 0? Yes. Let's try 8. 8 to the square, 64. Minus 8, that would be 56. And 56 minus 56, 0. Is 0 less or equal than 0? Yes. Okay, so when we write our solution set, we have that 7 up to 8 included is our solution set. So this is the answer. So why do we need this table? Okay, because when we graph these solutions, okay, we are looking for the values that make it less than 0. And that means that we find here between these two is the value that we're looking for. Okay, that's why we graphed, because here we graph this, okay, we graph this, and in the middle are the values that we're looking for. Okay? Perfect. Let's do number 2. Okay? I'm going to do another. Okay? Just in case, so that if you want to copy, already. Okay, so let's try another one. And now we're going to try one that has, let's say, a greater than value. Okay, so that we can see the difference, because this one had a less than or equal than value. Okay, so we would have number 2, and we would say x to the square minus 7x minus 3 greater or equal than 0. Okay, so the first thing we need to do is solve for the equation, right? So we would use factoring or completing the square or quadratic formula. Okay, so let's try to see if we can do it just by factoring. Okay, so we know we will have 2 terms greater or equal than 0. Okay, so first we factor. We have x, we have x. Okay, then we have the symbols. The first one is negative, negative times negative. Second one is going to be positive. Okay, so now we're looking for 2 numbers that multiplied gives us 30 and added or subtracted together gives us -7. Okay, so for example, 2 numbers that multiplied gives us 30. We can have 15 times 2, we can have 6 times 5. Okay, and that multiplied or subtracted together will give us -30, multiplied -30, subtracted or added -7. So let's think about 2 numbers. $15 and 2, maybe? No, right? What about 6 and 5? Let's try. If we were to have 6 and 5, okay, that means that 28, no. What would we use for this one? Oh, sorry. This one is -1. Sorry. I copied it wrong. I was looking at the wrong exercise. Sorry. Okay? Okay. So, x minus x to the square minus x minus 30 is greater or less than 0. Sorry, I copied the wrong exercise. Okay. So, we have x to the square minus x. So, we're looking for a number, two numbers, sorry, that multiplied gives us 30, and then added and subtracted might give us -1. Okay, so what if we have 6 and 5? Okay, because this one is very similar to the previous one, because 5, okay, and -6, if we add them together, they'll give us -1. Okay, so let's try x to this x times x to the square plus 5x minus 6x minus 30. Okay, and we know that we would have minus x minus 30, 0. Okay, so we have it correct. So that means that we have x minus 6, okay, and x plus 5. So where does this one become 0? At 6, and this one minus 5. Okay, so we come to our graph. Okay, this is the first thing we need to do. Okay, here we have the terms, here we have the answers. Okay, so we have x minus 6, x plus 5, and our solution set. Okay, so x minus 6, where does it become 0? 0. Okay, so the two terms are 6 and 5, right? Now, when we graph them, okay, x minus 6, where does it become 0? Here. And the term is included because in the original inequality we have greater than or equal. Okay, the same thing happens. X plus 5, where does it become 0? Here. And the term is included? Yes. Okay, so they are both included in the solution set. Okay, now, numbers to the right of 6, let's say 10. 10 minus 6, 4. So the answers, okay, right to number 6 are positive. And let's say to the left, let's try 0. 0 minus 6, negative 6. Okay, so these two gives us negative. X plus 5. Okay, we come to the point to negative 5. Okay, so then to the numbers right of negative 5, let's try. Let's try negative 1. Negative 1 plus 5, 4. Okay, so these terms are positive. And to the left of minus 5, let's try minus 10. Minus 10 plus 5, minus 5. Okay, then we multiply. Negative times negative, positive. Negative times positive, negative. Positive times positive, positive. Okay, so which terms are we looking for? We're looking for the ones that are greater than 0. Those are the positive terms. But let's put them into our number line just so that we can have a better idea. Okay, so we graph the numbers. Here's minus 5. Let's say that here we have 0. And let's say here we have 6. Okay, so we graph our points. They are included. Okay, and let's graph. We're looking for what happens from the numbers that come from negative infinite to 5. Are they included? Yes. This one's come from negative infinite, and all of these are included. Okay? From negative 5 to 6, not included. Okay, so these stay the same. And from 6 to the right, to positive infinite, they are included. Okay? So what values are we looking for? We're looking for the values that are going to give us a greater or equal than 0. Okay, let's try 0 in the original equation. 0 to the square, 0, minus 0, 0, minus 30. Greater or equal than 0? No. Let's try a number to the right of 6. Let's try 10. 10 to the square, 100. Minus 10, 90. Minus 30, 60. Is 60 greater or equal than 0? Yes. So we're looking for these values. Let's try to the right of negative 5. Negative 10. Negative 10 to the square, 100. Minus 10 is positive, so 110. Minus 30 is 80. And is 80 greater or equal than 0? Yes. So these are the values that we're looking for. So when we write our solution set, we're looking for numbers that come from negative infinite. Remember that negative infinite is never included. Up to negative 5. And negative 5 included? Yes. Since we have a lapse of numbers that are not included, we have to make a union. And they start again at 6. Is 6 included? Yes. Okay, because it's circled and because it comes from greater or equal. And then they stop at positive infinite, but positive infinite is not included. Okay, so this is the exact opposite of the first one. In the first one, we were looking for the values that gave us a correct answer to less than or equal than 0. Okay, but here, we're looking for the values that are greater or equal than 0. Okay, so since we have two sets, okay, the ones on the left to minus 5 and the ones to the right of number 6, then we have to make a union to perform the solution set. Okay, perfect. Okay, so make sure to check the video, to check the link under this video for more exercises on this topic. Okay, if you have any questions, please let me know.